Today's CHED speaker is the other half of the McCandlish mentor team. This is Mr. McCandlish. He mentors with the Computer Club, and he's also on the board of the center. He, besides currently being a cybersecurity expert, he spent 20 plus years as a New York State Trooper. So while you guys are having lunch, if you want some funny stories, there's a couple of really funny ones you would enjoy. You can ask him at lunch. Mr. McCandlish?
All right, so my name is Vern, and I'm the biggest geek you're ever going to meet. And anybody who wants to challenge me on that, I will meet during lunch and we can pull out our bona fides. I always tell people that because that way I either get to meet the biggest geek in the room or I am the biggest geek in the room. And I meet people who want to at least challenge me. So as my wife said, I had 20 years in New York State Police, but I started programming around 1980 when a math teacher that I was friends with his kid took us out to Niagara University. I started programming in a language called Fortran, and then I later learned Pascal. So that was my introduction. I've been programming computers for fun and profit for 38 years. But what I wanted to talk to you, and the title of today is DNS for fun and profit. Okay, so it's also low-cost geekery. And what I really wanted to work on was a really tech-heavy topic that is actually, we use all the time and we might not think of it. It's ubiquitous with the way we work on the internet. And also offer some things that you can do to use that, what you're going to learn today, to your advantage to make your internet experience a little bit better, protect yourself a little bit more, or if you want to be a little evil, how you can actually disrupt other people while they are doing those types of things. I actually gave this presentation to a junior achievement class earlier this week from Atlee High School. About half the room was filled with circuitry, $15.99. And the one thing I did by mistake, but I'm going to show you guys anyway, apparently the school didn't want me to show you how to build an open VPN so that you could, actually connect from anywhere in the world and use your stuff. All right, so I'm going to go with a quick little pre-knowledge here. Basically, computers on the internet, like everybody in this room, if you wanted to talk to somebody else in this room, you could just look around the room and you could see that person, you could go over and talk to them. That's the equivalent of your local area network. That's like what's in your house. If you have a dishwasher in your house that is smart, and you have a refrigerator in your house that is smart, the two of them can see each other. And they actually use something called that media access control address. It's called a MAC address. And what that allows is the machines can just talk to each other. They don't have to have IP addresses, they don't have to have any of that type of stuff. They can just see each other and they can talk. But if you wanted to talk to somebody outside of this room, the first thing you would have to do is figure out where they are. And we do that on the system with a naming system on the internet called domain name server, or domain name system. So we've got both IPv4, that's the classic 4 address, and then you've got IPv6, which is, again, somebody once said, who would ever need more than 64 kilobytes of memory? We think IPv6 will be enough. I want to live long enough so that it isn't. But the idea is, if you wanted to send a message to somebody outside of this room, you would have to know where they are, and I'll use the mail analogy here in a minute, but you don't have to know exactly how it's going to get there. You don't care what transports your message. You just care that the message gets there. I'm sure some of you probably have Skype, some of you probably have Snapchat, some of you probably have, well, you guys use Slack for the team. You don't care what route the packets take. You're just trying to make sure you have the right person addressed. So I'm going to talk about the domain name system. So all machines have names. You guys know Google.com? Everybody knows Google, right? Uncle Google? Well, what's its address? How do you actually send packets to it? It doesn't actually answer to Google.com. If I just put Google.com on an envelope and tried to put it on the internet and it didn't do any lookups, it wouldn't go anywhere. I have to know the numeric address. So I use my site. So I use malanalysis is something I came up with a long time ago because I did malware analysis. So malanalysis was something that I came up with, and that's the address for it. So it's 4 numbers between 0 and 255. That's 32 bits of information, and that's the old IPv4 addressing system. So the analogy I use down below is that's my name. That's Jenny's phone number. It's not actually my phone number, in case any of the old people recognize that in the room. And that is a fake address. Any of the young kids know that's Jenny's number?
I don't think so.
From the song?
Yeah.
8675309. Okay. But the idea is, if you needed to get me a message, if you wanted to mail a letter to me, what do? You put my address on the envelope, and you put it in the US mail. Do you care which carrier takes it to me? Do you care which post office it goes through? No, all you care about is that it finally gets here. But before you know that address, if you just have me, you say, hey, I know Vern McCandlish. How do you get that address? Now, some of us used to remember phone books. Sorry, hon. You have the address, you've asked somebody in the past for an address. You could call 411. Nowadays you go on Google and you type the person's name in and you get their address up. And computers do something very similar. They say, hey, I want google.com. I want something to tell me what are these 4 numbers. So I'm going to stick to IPv4 today. But they want those numbers so that they can we can start communicating. And computers use a system, and on Windows it's called NSLOOKUP, and on Linux and a Mac it's called hosts. And you put in the google.com and it will give you back that address. Now, where does this naming system come from? Well, the first thing your computer does, as soon as it looks in a file called the hosts file, and this is what we're going to use for fun and profit in a bit, because if you already have the address, that's the equivalent of I have an address book at home, and I open it up and I already have the address. I know which address I want to send that letter to. And the second place is if I actually have to, and that's, okay, if you go to technical, that's located on a Windows system, it's located in sys32 drivers, etc hosts, and on a Mac system and a Linux system, and that's also true for Unix, it's in the etc host. And after it checks that file, if it says, hey, google.com isn't in that file, I don't know what that is, it now says, hey, when I got my IP address, when my Verizon router gave me my IP address on this network, it said, hey, if you have any questions about names, ask here. So I send that question, it's called a query, to that location. And if that location doesn't know, it has an upstream place it's supposed to ask. And there's a whole chain, and it goes back to what they call a root server. So the whole internet is actually broken into 13 zones, and those 13 zones each have one root server. That's the authoritative source. And I'll tell you how that's easy to hack later. But the big thing is, and this is, I almost forgot to say it, when you ask the question, you always accept the first answer. On the base DNS system, the way it's set up, the first place, because you can ask multiple places the question, and you just take the first answer that you get. So you might start to see where we're going to be able to break this in a bit. So again, technical part, we're going to use something called the User Datagram Protocol, UDP. I've got tons of UDP jokes, nobody ever gets them. Anybody? No. I don't know if anybody turned it into a TCP joke for me. So the idea is there's 2 main services that we use for this. It's bind or it's DNS mask. I prefer DNS mask because it's small, it works better at smaller scale and allows me as a user to manipulate it better. Bind is what you're going to find all the big name servers use. Again, it takes the first answer. You've got the root servers, and there's a whole, if you would just imagine from an analogy, if I needed to add, if he's the root server down there and I'm starting here, the question would just get passed down and back, just like a game of telephone. But since we're dealing with computers, they're passing digital copies. They don't have the telephone mistake. So real quick, this is what a UDP packet looks like. And you can see I'm querying what google.com is. So I've broken this out using a program called Wireshark. So you can actually see what the actual package looks like. It's more human readable. But this is what it looks like up here. It's just a bunch of 0 through FFF, a bunch of hexadecimal characters are represented here. And it says, hey, what is google.com? And it's going out to a name server, and that name server replies back and says, hey, so you wanted google.com. Well, now Google does some load balancing, so it has a variety of places it can return you to, because if everybody who wanted google.com got the same address at the same time, that would be a denial of service attack on Google. So it gives out a variety of addresses. It has a whole pool that it can answer from. But that's the address on this instance. If I tried to do anything with Google after doing this DNS request, all of my traffic would go to that IP address. I'm going to skip the exercises right now because how you can do this for fun and profit. So,
I have a question.
Yes.
So, how many DNS addresses do you have for a typical website?
Well, this is where we're going to hack it a little bit.
Okay.
And I'm going to show you some pictures here. So like my website, there's only me. But if you go to WTVR, if you go to the New York Post, then what you will also get is they will say, hey, go get these other resources from these other websites. And the reason why we use the address is just like as a, I'm sorry, look at the mic. Just like we as humans can move. So I moved from New York to Virginia 4 years ago. Well, I didn't change my name, but my address changed. So anybody who was sending me email, I put a change of address in the post office. So anybody who was trying to mail me at my old address would get forwarded, but that only lasted for a little while. That would be a redirect on the internet. And then what needed to happen is I needed to update my address in all those databases where people would look for me so they could send me new stuff. And that's the same type of thing. The 4 numbers for any given site on the internet can change. The actual name doesn't change. So what I want to be able to do is I want to be able to control what results are returned for certain names. So anybody ever seen those ads where it's got like a picture of a 25-year-old person and it goes, this person's 80 years old and the medical community hates them. You know, stupid ads like that. Or hey, here's a gambling ad. Or hey, other nefarious things. Well, I'm a malware analyst. One of the places where attackers get leverage or get access to your computer is Google is a really hard place to get into. They have really good security. So is the New York Post. So is WTVR. But they buy, or they actually get paid to put ads on your screen, and those ads are delivered by a third party, and their security is not so hot. And the malware actors will try to get the malware into those ads. So when you go to the web page, you go to a web page you trust. You go to, I keep using WTVR because I've got it as an example here in a minute. But you go there, and you will get ads served to you from a third party. Well, some of those are the really stupid ads, but a lot of them have the potential to be malicious. Now, I do not advocate blocking ads because I don't want to kill revenue for somebody. I am doing it because it is such a dirty system right now that I want to be able to control the ads that I get so that I don't have to worry about malware coming onto my systems. So if I return a number, there's 2 that you can use. There's the classic, which is I'm gonna lie to my system. If my system asks for an ad server, if my system asks for a site that has to do with gambling, I'm going to return either 127001. There's no place like home. That's the local host address. That's the home address. The downside to that is that a lot of the website will, or the website with the browser will see that as, oh, you're trying to spoof me. So again, this is an arms race that we go back and forth on. 0000 is also an unroutable address. That is not a routable address on the internet, but it's still valid because all numbers have to be between 0 and 255. So I just put that in, the request fails, and I don't get the ads. I don't get those gambling sites. Now, I can also block other sites, and I'll show you where I go for this. But the example I'm going to show you is both the New York Post, because the page changes, and then I'll show you the TVR because the page doesn't actually change, but the ads go away. So we want the content, not the ads. And again, I'm doing this mostly for malicious, but as a parent, I can also control what shows up in my house. Because I can block by category as well. So this is a New York Post page. I've cut this out on the right-hand corner of the page, and when I browsed it without the ad blocker in place, and by the way, I'm holding this because I use one of these as an ad blocker, and I'll show you how to do that, Victor. I saw the smile. But here's the ad, and then here's the same website with the ad blocker on. And with the ad blocker on, you can see this, hey, how to follow us has moved up, because the page did not have space reserved for the ad. Whatever that ad server provided as the ad was going to go in there, and it was going to be made to fit. So now WTVR, the other morning, I was checking it on my tablet, and this is actually, the nice part about this is I get this ad blocking on any device on my house. Any smart device I bring into the house gets this ad blocking because I have one of these in my house doing my DNS. Because I control what the first answer is. And remember, it said it takes the first answer it gets. Well, since one of these is in my house, it's the fastest to respond. But I went to TVR the other day to see whether school was going to be closed. You guys ever do that? You just wait for Andy Jenks to call? So I went there. So this is the one without the ad blocker on. And you can see there's a banner right here. And then there's an ad over here for the Health and Fitness Expo that was coming up this weekend. So here's the one where I have browsed it with the ad blocker on, and you'll see the space is still there. The stuff hasn't moved up, and then this banner is gone. So these are just two examples. Again, these are ads, but the biggest thing for me is I want to be able to control the malicious things or the offensive things from not even getting an answer in my house. Now, the other reason why, and I talked about this, it's also really easy to attack. This system is trivial to attack because it is UDP, which means that nobody cares whether the packets get there, nobody cares whether there's a response, and it's also plain text. When I do that Google search earlier, when I did the DNS lookup for Google, everybody between my computer and the actual final name server that answered could see exactly what I was asking. They could see the question. So that's very insecure. But the other part about that is if I got down to about Mariana and the packet's going out to the end to get an answer, I could just have her give a false answer. Hey, she wants to hijack the traffic, so she's going to keep sending it up to the real root server, but she's going to give a false answer, and you're going to get directed to the wrong place on the internet.
So it's a mobile redirect?
It's not even a mobile redirect; it's a hijack. So and it doesn't. It could actually be, hey, while the packets are coming down this way, I could just be standing here and watching, and then I could just come back to you and go, the answer is 1, 2, 3, 4. And the packet, the real question's still going out, and when the real question comes back, so you'd eventually get a response to your original query, so you would have gotten 2 answers, but you throw away anything that isn't the first. So it is one of the simplest ways to hijack somebody on the internet, because if I know you want to go to malanalysis.com, but I want you to come to a hijack page that has malicious code on it, or something else, some other way to attack you, then I just give you a bad answer and you never get to the real site. And just so you know, advanced actors will use this, and they will actually wait for specific victims to ask for things. So if you have an advanced actor who wants to do something, and I'll just use like Iraq as an example. Somebody wants to do something malicious against people that might be doing business with Iraq, they might wait to see, hey, is somebody asking for the Iraqi embassy's webpage? And if they are, let's pull them in. Let's see who they are. Let's identify who's doing business by getting everybody from the Iraq that's going to the Iraqi embassy webpage to come to us first. And then we'll redirect them. Their browser, it will look seamless. They'll never know that they came through us. But we'll be able to tag every single person just by hijacking that DNS request. So what do we do about that? Okay, so first I'll get into, so this Pi-hole is a very easy project. It's one bash command. It's scary from a sense of as a developer or somebody who talks about information security, because I'm going to tell you to download a bash script from the internet and run it. Okay, that's intrinsically bad because it's not signed, you haven't hash verified the contents, but it is open source, so you can download the bash script and make sure you got it. It's off of a GitHub page. And then when you run it, and it takes about 5 minutes total to run, the Raspberry Pi on your network can now be your name server. And you can actually look up and you can add things, you know, maybe I want the ads from the New York Post to show up. So I go and I say, hey, anything that the New York Post is trying to give me, send me those ads. Or I can say, hey, I don't want the New York Post at all. I want to block the New York Post in my house. I can go there and add it to a blacklist and say, no, that just doesn't get an answer. And the nice part about this is this has no fans on it. It's completely solid state. And it takes about 4 watts. So the amount of energy that I'm using, my wife will attest. I would build new systems, and I would take the old system and I would put on the old system, you know, it'd be down in our basement, it was our gateway, and it was our filter, and it did all this stuff, but it was probably taking about 250 watts. And it made a lot of noise, and the one I tried to, I actually got a real server one time to try it. It sounded like a jet was taking off. So, the nice part about this, and now this can't be your gateway. I say that being a security incident responder who has found factories that have a Raspberry Pi as the gateway for their ingress-egress from the factory. It shouldn't be. How about that? It shouldn't be your gateway. You can't really use it at your house because the most you'll get upstream and downstream combined is about 80 megabytes. And that's if everything's running perfectly. So, but DNS, you saw how small that packet was. Even if you did 1,000 of those a second, you wouldn't get close. Do something like this. All those ads, they never get pulled down. So you're actually saving bandwidth in your house. Now Nowadays, you know, back when I had a 300 baud modem and I increased to a 1200 baud modem and I was ecstatic, you know, bandwidth was a huge issue. Now most of us have, you know, we're measuring our up-down speeds in, you know, 10 to 50 to 100 megabits per second. Somebody in here probably has gigabit connections. But you can use a Raspberry Pi for this. It's really easy. And this is what the network looks like. So here's my wired computers. Here's my access point, my wife's tablet, her phone, my tablet, my phone. All these things come off the Wi-Fi access point. And my home network behind my router says, if you need to ask a question about where something is on the internet, the first place to ask is this Raspberry Pi right here. And that's where it gets all the answers. I mean, and I don't mean to, it really is that trivial. Now you can make it more complex, which I have, because I want to learn. So I keep breaking it. And then I try to figure out what I broke, and I try to push it. But the idea is, if you just want to start with a Pi hole, then you need one of these, and you run one command and configure your router at your house so that it says, hey, all name server requests start here. So just to end, you know, I said that there was no security in DNS. There is a movement to try to get security in DNS. Imagine if you had an entire world that didn't wear their seatbelts, and then you passed a law and said they all needed to wear seatbelts. It would take decades to actually get that change to really take traction. I'm telling you the real world truth about 1984, because that's when most of the seatbelt laws between about 82 and 85 in the United States came in because of federal government pressure. But it wasn't until the late 90s I started to see I did the stats, I started to see over 80% actual compliance with seatbelts. Well, we have this new idea, it's called DNSSEC, or DNS Security Extensions. And the idea is that root server uses a signing key so that when you ask the question, you validate that the answer comes from him. So even if I answer first, you're like, that's nice, I don't know who you are, and you throw it away. The problem is that we still have about 80% of the internet that's not doing this. And there's a very slow adoption for it. Because most of the attacks, again, these attacks are not stealing money, they're targeting people. Or that hijack attack. They're targeting individuals. They're being used in targeted attacks more than they are in mass redirection. And again, the biggest problem with it is if you do any type of encryption, you do any type of cert issuing or signing, is management of your keys. Because that just becomes a huge issue. Because if you don't, it's called key rotation, but if you don't change things often enough, what will happen is you can't validate that your key hasn't been stolen. All right, questions? As I can talk about, so the other thing I'll talk about, the other system I have at home, because this is what I have an OpenVPN server out in California, and my tablet and my phone connect to that no matter where I am. And I have my DNS, the same setup that I have on one of these at home, I have out in California. So when I'm at the Deep Run High School and I connect to the Wi-Fi, I'm punching through to my server and I'm getting all my DNS requests resolved out there. When I'm at work, the same thing. I was at a hotel in New York not long ago. Who likes to get on hotel Wi-Fi? Not me. Now I do, because I get on and all the hotel Wi-Fi sees is an encrypted tunnel on port 445, the HTTPS type of tunnel. Goes out their firewall into my server in California, and then I can do whatever I want because I'm not restricted by their local restrictions. The other advantage of OpenVPN is how many people in here were for net neutrality? Okay, well, one of the ways Verizon can play the change of internet control from the FCC to the FTC is they can watch my traffic and they can see the places I go to and they can see the things that I'm doing. Well, if all they can see is an encrypted tunnel, they can't see the web pages I go to. They can't see that I'm going to Netflix to watch, Voltron. No, that would be my daughter. But they can't see what I'm doing, and if they can't see what I'm doing, they can't try to speed up or slow down traffic that they want to speed up or slow down, because they no longer have the visibility. And in the forensics world, we call that metadata. They don't care that I'm watching Voltron. They care that I'm connected to Netflix. They can tell that I'm connected to Netflix, and they're going to do something either to make, either Netflix gave them money so it would go faster, or maybe Amazon Prime gave them money so Netflix will go slow. That was really the threat of net neutrality. So having a tunnel that goes out to your own server means that the local ISP can't play those games. Time, 30 minutes. That was about a 45-minute presentation. Questions?
DNS script?
You mean the attacker?
The open source software DNS script.
Well, there's other ways to do it. This is the way that and I put it up in the slide earlier, the actual place that controls naming on the internet, this is the one they've adopted. This is what they're pushing. DNS script is just another way to be able to do your DNS queries without having to worry about people in the middle watch it. But whatever you're using as a name server has to have the answer, and if it doesn't, it starts asking plain text questions on this side. So even though this part of your connection will be encrypted, this part isn't. And the other thing is, even with DNSSEC, the actual asking the question is unencrypted. It's just the return answer has a little bit of digital signature code in it that I can validate using a public key that little piece of thing was signed with a private key. Yes, sir.
Why isn't someone selling the pi hole concept?
Because somebody already gave it away for free. It's open source. It's free open source software.
So it's Linux, but there are a lot of companies selling it.
You can buy kits.
Yeah, there are things that you can buy. I'm trying to think of the name of one of them, but they're basically it's actually designed for the Internet of Things type of thing. You just put it in your house, and it does all of this stuff on your network. And so I'm looking at I'm building one more that's more solid state as a gateway with multiple zones. But there are devices like this that you can buy, but I've never played yet. And I'll be honest, I've never really looked at it from a commercial perspective because I want to know how to do it. Because then if I know how to do it, I know how to attack it. And then if I know how to attack it, I can defend against it.
Does GE still do matching gifts?
Yeah. I know where that came from. They might, if my wife would like.
They do GE volunteers.
They do GE volunteers, I do that. Actually, the biggest question I had that I told my wife I kind of threw my CISO under the bus because she wasn't there when the question was asked originally when I had junior achievement is does GE take high school interns? And the closest we got, we had Jake Smith between graduation and starting at UVA, but we're working really hard to get that down to 16-year-olds.
That'd be cool.
It would be awesome. And everyone we've ever had in has been awesome. So it's not like, everybody who's seeing it is like, yeah, we want these people in. It's, lawyers.
We'll work for pizza.
Anybody have any other questions?
How does something like that affect the website, like YouTube, where it's the,
Okay, good segue. I owe you Sloppy Joes later. Well, so one of the things that I mentioned, I gave a presentation like this a little while ago, and one of the things I said is so Google gets around this, this DNS blocking issue and ad blocking, they serve all the ads themselves. So because they serve all the ads themselves, you get ads if you're on YouTube. I actually pay for YouTube Red so I don't have to see ads. But the concept is they serve from their server, so if I blocked their ads, I would also be blocking their content. And I can't tell the difference between the two. Now, I say that Google's really good. Google still had the same problem, because guess what they were doing? They were still buying stuff from third-party vendors to put into their ad servers. So does anybody remember what story came out last week?
Why?
If you were watching videos on YouTube, some of the ads that came up were mining cryptocurrency in the background while you watched the ad. They were little JavaScript loops doing just a little bit. So, and the thing is, imagine if you only steal a penny from somebody, does that person really care? What if you steal a penny from 300 million people? How much money did you just make? 3 million. So it's the old Superman 3 plot line.
$30,000.
Does anybody remember Superman 3 plot line?
Or Office Space.
Office Space plot line, take the fractions of the penny off the transaction, truncate it. But the idea is, to answer your question, it doesn't really affect the website, but what I see in this arms race, more places are going to go to the YouTube answer. or the Google answer, and then there's something else that's gonna have to happen. But again, I block the ads on places as I'm browsing so that I can control. But if I'm in a browser, my desktop browser, I have JavaScript blockers. And I have to explicitly whitelist any site that's gonna be allowed to run JavaScript. So I don't have to worry about it on my desktop browser. I don't have that on my tablet unless I root my tablet. I don't have it on an iPhone unless I jailbreak it.
It is.
What?
Jailbreak.
I'll tell you later.
Uh-oh.
No, it was why I couldn't run something that I was supposed to get done paperwork-wise because you had it blocked. And I
Oh.
had to,
It wasn't on the white list.
yeah,
Did it save us money?
No.
no.
Because it saved us money, it was worth it. Other questions? I'm gonna stick around for lunch, so if you guys wanna, but again, my wife has already set me up that I have to tell war stories during lunch.
I said if they ask you.
Okay.
Thank you, Mr. McCandlish.
Thank you.